Okay, so a student pointed out to me after class that I made this a lot harder than it needed to be. So from this step right here, what we want to do is recognize that this is now a perfect square, because if we take that, x fourth is really x squared squared, and what this 1/16 x to the fourth is 1/4 x to the minus 2 squared. And so if we square that whole thing and we check the middle term, we find out that the middle term would be 2 times x squared times 1/4 x to the minus 2, which becomes 1/2. So this is a perfect square. It's x squared plus 1/4 x to the minus 2 all squared. The middle term is correct. So what we have is the integral of 1 to 2 of the square root of that thing squared dx. And so now the square root of the square is just this argument here. So from 1 to 2, x squared plus 1/4 x to the minus 2 dx. And now I've got a really easy integral. X cubed over 3. Let's see, what would this be? This would be x to the minus 1. So minus 1/4 x to the minus 1. Let's just check to make sure that that's right. Take the derivative. -1 times -1/4 is positive 1/4 x to the minus 2. Okay, and we're going to evaluate that from 1 to 2. So we'll have 2 cubed over 3 minus 1/4 times 2 minus 1 cubed over 3, so minus quantity, minus 1/4 times 1. And this equals 8/3 minus 1/8 minus 1/3 plus 1/4. Common denominator 24. So we have 64, so 8/64 minus 3 minus 8 plus 6, which is 70 minus 11, 59/24. Is the length of this curve, starting at x equals 1, ending at x equals 2, 59/24. Okay, I know that's a much better solution to this problem. So recognizing that after multiplying these terms out, that this is a perfect square. It's x squared plus 1/4 x to the minus 2 squared. That gives us the right middle term, 1/2. And so then the square root and the square cancel each other out. And we're left with this easy antiderivative.